Hello everyone. So today I will be doing some stuff with this CLab project. So I think for during the last video are we are trying to do some research on the concurrency and how concurrency work in C programming language. So I think I was able to implement two threads for that one using the pthread functions. So going back here, let's see, concurrency. Yep, I think this is the one. Yep, I think this is it. So basically this is the thread. Okay. So basically we created a p thread here. So this is the join. We have a second thread here. So return from thread. Switch. And then we assign the value in R1. Okay. So we have two. We created one thread here. So this is the one. It's not exposed to purpose. So this is the thread 1, 2. Okay. So let's see. So each thread has its own registers and stuff. Then we can get it. Sequential application. So I think we can use the pthread int here at t, I guess. So as you can see, we are using the unsigned long int. So unsigned means it's only positive. Here, I think we can do it. Pthread int. Oh wait, t. I'm sorry. Thread, and then where is it? And then here we can do it. That, and then so we'll see. Here file run. So 3, 2, 3. I was thinking to implement code. So we have two threads here. The first thread is this one. So in this thread, it calls the function inside thread, and these are the subroutines that it is going to print. So the printed value here will always depend on this one. So it doesn't change. So 200, and then here I see. So if we want to get the return value for this one, we can just we always get the 200 plus 1, 2, 3 here. Yes, okay. So outside thread, so let's see. So in here we get the return. So return of the first thread, which is this, and then as you can see, it returns the 200 plus 1, 2, 3. Gotcha. Okay, so the return value here will be this plus the parameter. So the parameter for this one is 200, so 200 plus 1, 2, 3, which is 3, 2, 3. I think this one should be P thread T, because the equivalent type for P thread T is unsigned long int, so it's I think it's 0 to whatever the bit size for this. Just wondering, let's print something. Let's see, size of ph. Yes. %d. Okay. So LD. We'll see how many, how much is the assigned size of the thread that we just initialize here. So let's see. Okay. So maybe size of ph, and then f size of thread from thread percent ld dash n size of we should have an helper here. I see. 9. Oh. C size of. I'll check how much is. Why is it? Unary operators here, that evaluates. To 4 bytes. I see, 8 bytes. It's 1 bytes equal to 8 bits. Bytes to bits calculator. So let's say 8 bytes, 64 bit. I see. So there are 64 bits. Let's see. If it's 8 bytes, 88. So 8 bytes. So int is 2 bytes. So 1 bytes is 8 bits. So 2 bytes is 16 bits. So I guess 2 calculator. So let's say 2 raised to 16. 2 raised to 16. Where's the exponent here? Okay. So 2 raised to 16. 65,536 values. If 1 bit, so 8 bits. Wait. I think that's no. It should be 2 raised to 8. 256 values. If this, since this is unsigned, so 0 to 255 for 8 bits, and since the threads is 8 bytes. Okay, so if it's 8 bytes, so 8 bytes equals to 1 bit equals to 8. 8 times 8, 64. So 64, ayun, 2 raised to 64. Damn, that's a lot of values. Let's see. Okay. So based on what is shown here, a thread has a size of 8 bytes. So that's basically 64 bits. And as we can see here, that's a lot of zeros. I don't know, thousands, 100 millions, billions, trillions, and I don't know what's next after that. It's a lot. Okay. I'm gonna try something new. Let's see, multi-threading. How to do multi-threading? See. This is just the same. Okay. In here we wait for the thread, pthread join. Pthread create. After 5 seconds. Oof, this is cool. So assigned. So I have an idea. Where's the multi-thread? Thinking basic thread. C multi. Let's see. Multi-threading. Let's see. Yes. So shift key. So void C multi void something like that. Outburst in here. Thread P threads I was thinking that maybe we can add threads in here and then array and same thing. I forgot how to do arrays. Here in array type text blah blah blah. My plan is to push here. My plan is to push here the IDs and then each return for that the thread. Let's see. What's the best? Scalable. Excalibur. So here. So we have here an array of threads. So what I'm planning to do is we have here so we have here array of threads. Wait. I was thinking if I function inside a thread, function I see. So I was thinking that maybe okay. It's concurrency multi-thread. So can you push the threads in an array? Wait a minute. How to push an element to an array? Let's see. Forgot how to do this. Array. And we obtain the address. This one, address operator, position 3, on. Position. Okay. So my idea is here. Now, here. So array of threads. And then so we have a loop here. So the loop here is something like this. I less than 5. So at zero, so we should my intention for this one is to create 5 threads using for loop. So the for loop has values from 0 to 5, 0 to 4. So basically, we will create threads on each iteration. Okay. Okay, let's see here. Let's practice to map out our ideas. I'm not sure if this is the best way to do this, but just a reminder, what I've been doing here is only for recreational purposes. So my implementation and ideas, it always depends on my imagination, on how creative I am during that day. So I will not follow best practices in software engineering. So I will just implement what goes inside my mind. So in here, okay, so first we will create a thread. So process here, create a thread with I as ID. Okay, then here, so I'm going to put register there. Okay, and then it will goes back here. So the idea is that then here I think it's create a thread, then here I less than 5, so we can put it here. Yes, so by the way, this is the third part of the for loop. So where usually we put an increment like I++. So in here print the values of the array threads. So let's do it again. Okay, I think this is a good strategy. So in here we will create a function inside thread function, and then this is a void x, so it's a pointer. So in here we the return of that thread is always an unsigned long int, so we can just use the pthread t, and then so casting pthread t x there. Sorry. Thread x, and then usually there is a return. I think the x will be the index I will pass the index value, then return void yep, that's index. So in here what's my URL? What is this? Oh shit. F. Index I percent, I guess, percent D, then I. Did I? I didn't know. Okay, so new line 1. So in here we will create a thread. So thinking gotcha. If you want to get a return, breath thread. Let's see. We will do some for loop here. Equals to 5. This was sorry. Then we will do a p thread create. So p thread create. So I guess I can do it like this. R thread I. Oh no. Okay. An array of threads. Just create maybe a p thread. T current thread. Let's say something like that. Current thread, and then here we have current thread, and then wait. Basically, we have 3 values. P thread create. P thread okay. So we need to add P thread, something like that. First is the new thread. Create a new thread starting with the execution of start routine. Creating a thing. P thread attribute. But I guess this is null. This should be null. Null inside thread, and then we will pass the void. Okay. and then array of threads. This word I equals to and current thread. Wait, what is this? Gotcha. Okay, so we will cast it first to p thread there, and then should I exit that? I'm not sure if this will work, but let's see. Here, extend vertex. Okay. No, we don't do that. See, multi-thread. Include C multi-thread. Let's see. Multi-thread. Not sure if this will work, but the next that I'm going to check is this. So we already have here the same thing there. And there's length here is size of array threads divided by the size of the thread T, right? P sorry, there, and then we will contact this one. Length the let's go make run. Oh no, dynamic array, diba? C dynamic array. Malo. I think we can do this one. Malo size and gotcha. So here I think for dynamic when doing some dynamic array in C, we need to, I think during initialization we need to assign we need to allocate a memory value for that address. So in here I will create a pointer. So the pointer will be p thread Actually, I think this is not here. Sorry. So in here, I think initialize. What's this? Initialize. No. So p thread t, then array threads pointer ptr. I was thinking that malo, let's see, size. So the size for this one is size equals to 5. So I think we don't need that. So we can just do this 5 times size of p thread t. Let's see. There. And then gotcha. I see. So we don't need this one. We can just ptr. Array threads ptri, something like that. Array threads ptr. Should or maybe something like this, or there, make run 0 1 2 3. Where nako. What values there? So it created, why it only creates 0 1 2 3? How about the fifth value? Where is the fifth value? So yes, maybe oh, the 0 1, but the 3. Let's see, why is it? I just read. Changes, as you can see. Okay, it's not consistent. Okay, as you can see, inside threads 1 2. Oh shit, why it execute? Okay, cancel a thread. How to cancel a thread? Cancel. Okay. So thread, I have an idea. So we will cancel the thread during this loop. We will cancel the thread after we assign the return value. I think p thread cancel, then current thread. Then we'll see what's the current behavior for this. Only one, and here we have, why is it? It's not consistent. Why is it consistent? It's the word. So as you can see, the first, okay, before the index 0 completed its execution, how come? Then we have 2 in here, and yes. This is really cool. And I see. I think in here I've canceled the thread here. So before the loop, wow, okay. Huh. This is weird. Index thread. So the first index has not been in here. The second, the 0 and 1 index has already been completed. So the loop in here, the loop is already completed, but the thread is still processing. This is weird. And as you can see, the new line operation has not been processed yet. I was thinking that what does it looks like? Let's see. We need to have a new terminal for the top. Detach terminal. Top. Let's go. Oh, so it's not showing. Okay, it's not showing. I see. So basically, the way I see it here, as you can see, it's possible that the loop has already been completed, but the threads are still processing. Okay, so the threads are still processing. I think you can think of it like a background process. Because in here, I think to make the consistent, should I add a new line here? But how do I force this to be sequential? I'm thinking to make these threads sequential, like thread index 0, thread 1, thread 2, thread 3, and thread 4. Threading is really good. So threads, so thread process. Try to finish. So you can add. Okay, you can add thread 1 and then p thread 1 join. So I guess it shows here the p thread 1 join. We will force this to null. It shows here that synchronize the I love this. So I guess it should, let's see if this will work. So it works. Okay. So we can add a new line here. It should be so I think I can do this soon. So we can use the p thread join. This function is a cancellation point and therefore not marked with row. Okay. So if this will cancel the thread, I think we no longer need this one. Okay, so I have here, we can see, we can make this as sequential. Wait. Synchronize nodes. Sequential means definition. Di ba pagkasunod-sunod, I'm sorry, arrange. Okay, so how about the opposite? I would say that non-sync. Okay, antonyms. I'm sorry, antonyms. Synonyms. How about non-sequential? Okay. I think I know now how to. This is multi-threading sequential. So we can just do it. Here's multi-thread sequential. Okay, multi-thread sequential. Okay, so sorry. Sequential. There. And then let's go back here. Multi-thread sequential. That's siya. So in here, multi-thread sequential. Okay. Haha! This is sequential. Then we'll create a new file here. C multi-thread non-sequential. Okay. So C multi-thread non-sequential. So this is still void. So I get it now how to oh shit, I forgot to I need to release allocated memory. Okay. So we allocated the memory here. Problem is why is the link. PTR, then let's say 2. What? Inside thread. I think I should give an index for this one. How about the ID? So the ID, I need to know the ID. ID. So pthread cancel. So ano pinagkaiba? Cancellation request, but the actual termination depends on whether the thread is in a cancelable state and if it handles cancellation. I see. So this one force, but okay, this is what I want to know. Current thread. Pthread current self. Gotcha. So basically pthread T equals thread ID and then pthread T, it should be I see. Okay, pthread self override and then okay, percent. I would say that inside thread index %d LD, this should be LD, and then with ID %LD. So here we can pass the thread ID and then We'll remove this one. Right. So 2.140.9. So what's this same value? So the array is not working. 960. It's changing. I see. So it is sequential. You know, I was thinking that maybe I can return the okay. I think I can return the thread ID, and then if we will return the thread ID here, I can push this ID inside this pointer. This should work, right? It should be the same. How will I do this? Pthread shall equal to obtain the thread inside. I pass the I. Why is it not working? Why? Pthread. Hey. How about that? Since it should, yes, it works. 4128, as you can see. So we have 4 arrays. It should be the same value for 0 to 4. Let's see if it works. 0. Alright, it works, the sequential. So I see. So I guess array threads, I think they should be IDs. They should be IDs. Right. They should be IDs. Okay. They should be IDs. IDs with array threads, IDs between IDs. Array threads. Not sure what's happening. Why? Array threads between okay. IDs and IDs are in here. Create a 5 sequential threads. Print its index and ID. Here thread. In here we can do a for loop here. P thread P I equals to 0 and then still 5 since we assign value. So let's see. We can so P thread P current ID equals to P. Okay, how should I do this? Array threads PTR, then I, right? In array size equals to 5. Do like this. Array size. Okay. See, so we already have the values for the current ID. So we can print it here, something like this. Outside thread index I with ID equals to should be LD, so I and then current ID. Then new line. Make run 656 haha, it works. So they are the same, so I think this is good. Print the ID, including print the index and ID outside the thread. So basically in sequential, it reuses the same thread. So we need to prove if it really behaves like this. So this is my first concurrency in C. C concurrency sequential multi-thread. So the next that I'm going to do is we're going to implement a non-sequential. So still void inside thread function. Still this is void. Now index, and then here p thread. This is the thread. Okay. P thread T and then I. So still include as you can see, when I'm learning something, even though the code is already on the multi-thread sequential program, I still try my best to like not copy and paste all the program that's all the code that's in the that's inside the multi-thread sequential. So this is kind of a practice for me, right? Maybe to improve my crystallized intelligence or memory. So we'll see. Okay, if I can really implement this. So thread self. So we need to self. Okay, we have a problem. I don't know this error. P-thread self. Gotcha. Okay, we will return first the void. And then thread self ID. Okay. Thread ID. About ID. Print inside thread index thread I will say thread I index I with ID equals to %LD, then thread I, then thread ID. Why it's not working? Okay. I should put it down for here. STDIO. I'm not sure. I think this is not needed. P thread then self. Oh shit, what did I do? P thread self. This should be 29. Guess I need to reline because suddenly it's not working. P thread. Okay, P thread. So I guess let's copy and paste this. Multi-thread, non-sequential. Initialize and declare variables. Okay, so in array size equals to 5, then p thread t. So this is the array thread ID is ptr. So then we will assign a malloc here. So 5 size times the size of the thread t. Does that make sense? Okay, so here create 5 non-sequential threads. So what's the thread? Should I put it right here? Goes to 0. So here we will p thread. I think yes. We can put a p thread here. current thread, but we will cancel this thread. So we will not do a join because the join will force our loop to wait for the current thread to finish. So it's not really ideal in this case. Current thread. Okay, so what should I do here? I think this. So in here, then we will create the thread pthread create. So let's see. So we will assign the address current thread, and then here pthread attributes, I don't know, null. This should be null, and then we have this inside thread, and then we will pass a value of the index in I. So thread. So basically we should be able to get the ID. Let's see. How did I do it? So threads. So basically this will return the thread ID. Yep, see, okay. I think pthread okay. Array thread ID is I equals to current thread. Oh no. Okay. So pthread T. Wait. I just maybe something like that. Did I do it like this? Why do I need to do it like this again? Pthread T, current thread. I think it's no longer necessary to put, but here it should be non-sequential. Then pthread cancel. So I'm not sure if this will cancel. Then print the array threads thread IDs outside of thread. So we can do like this. Five. This. So we can do it like this, and then so basically outside thread index %b with ID equals to %LD. I then R thread I. See, then we will add a new line. Here they should be here. C multi-thread non-sequential should be non-sequential. That's C. C multi-thread. Will this work? Oh, no. Okay. Non-sequential. Oh, alright. We have here the non-sequential. So 0, 8888, 3, 704. Yes, it works. Then 4 is 00, 86400. So basically the loop earlier, okay, so 0, 1, 2, 3. Now the loop has already ended, but the thread with an index 4 is currently processing. So since the loop is already completed, so the outside thread already executed. Love this. 2, 2, 1, 1, 2. How about 3? Let's see if this is consistent. Okay. Let's see. 4, 184. Okay. Let's check. 2, 2, 2, 2, 2, 2. Inside thread already executed. Oh, I need to free being and release the allocated memory. So we are trying to free the p thread t. Sorry. Array threads. Okay. Okay, let's see. So the index 0 is 5024. Gotcha. So I see. So in non-sequential threading, you cannot really predict when will which thread will finish first. So as you can see in here, if we want to force the threads to be sequential, I think if you will do it like this, the purpose of the thread no longer makes sense. So I'm not sure, but I think that if we start using threads, then the main goal of the program is to have a non-sequential operation. So the sequence of the operation is not really important. So I guess this is the kind, like those operation that let's say thread 1 is having let's say thread 1 is processing like heavy computation. So logically thread 1 will finish last compared to like thread 2, which only prints a text or a value. So yeah, I think this is really cool, multi-threading. So in here we learn how to use threads in a sequential way and a non-sequential way. So I guess this is for threading. I'll push it first. Non-sequential multi-thread in C. Haha, So it works great. Non-sequential. I think this one is no longer needed. So I run build chore, remove unnecessary type casting. So if you want to check this examples, so you can have it here. Yep. So you can just you can go to this repository and run this program. So just a heads up for the what do you call this, the folder structuring for this one. So all the examples of this directory, the X concurrency, will be placed here, and then we will export this C in this header file. So here, then in main.c we can just call this header so that we can show the example program that we just created. I think this works. So that's all for today. Thank you for watching, everyone. Bye bye.